Hi, Mrs. Farah here. This is a continuation of that 5.1 introduction. So we did square roots in the last video where we were simplifying all just plain square roots. They looked like that. In this video, just like it says, we're doing other roots. So this square root has an invisible, we call that the index of 2. We're going to look at third roots and fourth roots in this video. So the index, you can think of that as the number that tells you what size group you need for a jailbreak. So this is what the index is. That number right there, that is the index. So when it's a square root, like the ones we did in the last section, we don't even write the number there, but it's always a 2. So when it's a 3 and we circle our groups, we're going to look for groups of 3. When it's a 4 and we circle our groups, we're going to circle groups of 4. So let's just get started here. So 16, you're going to do the same first step. You're going to do a tree. So this is 2 times 8 and 2 times 4, and 4 is 2 times 2. So 16 can be written as, make this big, don't forget to write that index, 2 times 2 times 2 times 2. So now, in order to simplify this, I don't want to circle groups of 2 because my index is 3 here. I want to circle groups of 3. So the way I like to explain this is like a higher security jail. I need 3 people to work together to try to escape this jail. So 3 for your index, you need to circle a group of 3. This means out of this group of 3, still only 1 is going to make it out. This 2 will stay in jail. So this will simplify to 2 square root of 2. So same idea, exactly the same as last video. We're just, if the index is 3, we're circling groups of 3. So try this one on your own. You should get a 7 for this one, which means everybody breaks out. Nobody's left in jail. All right, let's look at another one here. This one, the index is 4. So this means I want to circle groups of 4. Okay, so I still need to do a tree on 162. That's a big number, but that's okay. I punched this in my calculator and I found out that it is 6 times 27. Now you might start with 2 times something or 3 times something. Doesn't matter how your tree starts, the bottom will always be the same. 6 is the same as 2 times 3. Those are both prime numbers, so that's the bottom of that part. 9 is the same as 27 is the same as 3 times 9. 3 is prime, so that's going to be the bottom there. And 9 is 3 times 3. Okay, so 162 can be written as, don't forget your index here, a 4, can be written as 2 times 3 times 3 times 3 times 3. 4 3s, right? Yes, 1, 2, 3, 4. Okay, perfect, because I need a group of 4 to do a jailbreak. So there's my group of 4 3s. Out of that group of 4, only 1 is going to make it out alive. So 3 will be outside the jail. 2 will be left inside the jail, and we need to put that index of 4 on our square root. Actually, I think I forgot to do that on this one. Go back up here and put an index of 3 on there. All right, so this simplifies into 3 times the 4th root of 2. That's how you say that. 3 times the 4th root of 2. Try this one on your own. This is what you should get for an answer, but I should have that index in there. 2 times the 4th root of 3. Now I just want to show you quick. I didn't have these in the notes, but you could add them in. This is just an example of when you have the same number under the radical, but different indexes here. This is a square root. Remember, if you don't see an index, it's a 2. So they all have 200 in there. So I'm going to do a tree for 200 over here. So this is the same as 2 times 100, right? 100 is the same as 2 times 50. So I'm underlining my prime numbers as I go there. 50 is 2 times 25. 2 is prime. And 25 is 5 times 5. Okay, so this is the tree for 200. 2 times 2 times 2 times 5 times 5. So that's going to be the same for all of these. All that's going to be different is the jailbreak part. So I'm going to write this as the 4th root of 2 times 2 times 2 times 5 times 5. Now in this example, I need groups of 4 for a jailbreak. If I look at this, I have no groups of 4. So that means I cannot simplify that further. So this is my answer. This is fully simplified. Now let's do the square root. So on the square root, I'm looking for groups of 2. So the tree is the same. 2 times 2 times 2 times 5 times 5. But now I'm going to circle groups of 2. Well, there's a group of 2. And there's another group of 2. This 2 is going to be stuck. So I'm going to have a 2 that breaks out and a 5 that breaks out. So outside the jail, I'm going to have 2 times 5. Inside the jail, I'm going to have that 2. 2 times 5 is 10. 10 times the square root of 2. So these look very different just because they have a different index. And then for an index of 3, same thing, 2 times 2 times 2 times 5 times 5. You might already think, oh, okay, group of 3, there's a group of 3 right there. Index of 3, I need a group of 3, so that 2 will break out. Remember, only 1 makes it out alive. So outside the jail will be the 2. Inside the 3rd root jail will be 5 times 5, which is 25. So that's the same number, 3 different indexes, 3 very different answers. That is it for this video.